Alright, in this video I want to talk again about defining the angles in static problems. If you have some type of, let's say we have a ladder, and the ladder is leaning up against a wall at some angle theta. Now we know the ladder has some weight that's pulling straight down, and the weight, the center of gravity or center of mass of our object, if it's a regular object, that's always the halfway point. So if the ladder has some length L, then on each side it's half the length away from either end. Now, if we're looking at the torque that the center of gravity generates, let's say either about this point or this point, but let's just say this point down here. When we're looking at that, we always define the torque as RF sine of phi. And we said that phi, this angle phi, is defined as the angle between R and F. So if we look at this part right here, if this is the force, this is our force down, and the half of L, this is our R, that would make that phi. Now, how do phi and theta relate? Well, theta here is related to phi by looking at this triangle. If this is our force, and this is half of L, and this is phi, and this makes a right angle, and this is theta, well, we know that any triangle, the interior angles have to add up to 180. So in this case, it's 180, 90, plus phi, plus theta. So when we look at this, we see that phi plus theta equals 90, or phi equals 90 minus theta. Another way we can think about this, phi, if we call this side, let's say, x, then phi, and we'll call this half L, that's fine. We'll call it R. Then in this case, phi, the sine of phi, is equal to x over R in our triangle. But if we look at cosine, because let's say we're not given phi, but the cosine of theta is also x over R. So if we wanted to define the weight, the torque here, the torque would be like our half L times this force times the sine of phi. But if we weren't given phi and we were given theta, you could have also called that 1/2 L times the weight, mg, times the cosine of that angle, this angle. So you just have to make sure that you remember the real definition of phi really doesn't come from looking at this triangle. It comes initially because phi is the angle between R and F. Alright, so that's just remembering how we get our torques when we're looking at something where in this case our beam is tilted, so they usually give you the tilt angle and not the angle between F and R.